Hello Gators, this was going to be 2.5 applying the power rule, 2.6 derivative rules, the constant sum, difference, and constant multiple rules. Let's take a look at our favorite function f of x is equal to x squared and use the definition of a derivative to derive the derivative. And you can see at the very end the answer is 2x, and that is a formula that will give us the slope of any tangent line at any x value. Let's go to take a look at f of x equal to x cubed. Same approach, start with the definition of a derivative. Now to expand a cubic, you need to know some of those rules to expand. But in the end, we can, and we get the answer 3x squared. Let's do x to the fourth power. X to the fourth power takes a little bit more algebra to expand to the fourth power, but in the end, we end up getting 4x cubed. So let's recap what we just saw. When the function is x squared, its derived function is 2x. When it's x cubed, it's 3x squared. And x to the fourth, it's 4x to the third power. So we haven't done this, but if we follow the pattern, it should be we take the power, make it a coefficient, x, and then we do one less power, which is 4. So in general, the power rule is f of x equals x to the n, where n is the power. It'll be n, x, and then it will be one less power. It goes down 1. All right, let's do some examples. I want to find the derivative. This is to the 37 power, so this will be 37x, and one less power, that's 36. Y prime equals, we're going to use 9 as our coefficient, x, and we have one less power, which is going to be 8. Not so easy examples. Here you want to rewrite so that it looks like a power, so x to the -1 power. And so when we differentiate, it'll be y prime is equal to -1 will be the coefficient, x to the -1, and you want to go down a power, so you want to subtract. So let's simplify, and this will be y prime is equal to a -x to the -2 power. And if you don't want to write with negative exponents, it'll look something like this. Let's go over here. We want to rewrite y is equal to x to the -4th power. So y prime will be equal to -4x to the -4, and we're going to want to go down a power. And then we're going to have y prime is equal to -4x to the -5th. And if you want to write with positive exponents, it'll look something like this. Now these other functions, take a look at how we do a root. We do it to its fractional power, and we operate the same way. And again, number 6 is a very similar example. You just write it to its power and follow the rules, and you're going to get a fractional power for an answer. Some little tricky examples here. When we have something like this, we want to use our algebra skills to put these together. And so we're going to use our law of exponents. This will be x to the 1/2 power. And once we do that, we can go ahead and use our rule. And you can get to this point. I like to get my fractional powers into a radical, and then I evaluate it at 7 by just putting 7 into the derived function. Over here, I wrote out my powers. I used my exponential rules. I got 10/3. I went ahead and found the derivative. I evaluated at 8. And remember, 8 to the 1/3 power is a 2. And then I went ahead and simplified. Parallel tangent lines. So these two functions, we want to know at what values of x do the graphs of f and g have parallel tangent lines. Well, parallel lines have the same slope. So let's figure out the slope for f of x. That'll be 4x to the 3rd. And g of x, that'll be 3x squared. And when they're the same is when we set them equal to each other. And so that you don't lose any roots, you should bring everything to one side and factor out the greatest common factor. So the answer is going to be at 0 and at 3/4. So both of these answers will have, at these points, the slopes will be the same. Derivative rules. The derivative of a constant is 0, and that's because a constant is a horizontal line, and horizontal lines have a slope of 0. The constant multiple rule, if you have a derivative of a constant times a function, then you can just take the constant and then times it just by the derivative of the function. So in this example right here, I have a 5 times x. That is a constant. I can really take it out and just find the derivative of the function, which is 1, and so the answer is 5. Sum and difference rule. So if you have two functions that are being added or subtracted, just figure out the derivative of each and put the plus or the minus sign in here. So for instance, the derivative of 5x plus 5 is, the derivative of this is 5, the derivative of the constant is 0. And subtraction works the same way. All right, let's go ahead and find the derivative, and we can see we have a sum and a subtraction. And I went ahead and rewrote the exponents so that I could start taking the derivative. And so this is going to be 4x, and then I'm going to multiply, so that's plus 5, and then I'm going to subtract 1, that will be x to the minus 2. You can leave it this way, or you can write it as positive exponents if that's going to make it easier for you to evaluate. Y prime, and I've already made them into exponents that I can use easily. So 1/2 times 8 is 4x, and I'm going to subtract 1, so that'll be negative 1/2, minus 6 times 1/3 is 2, x, 2, and 1 less is 5. And don't be fooled by this one. This says pi. This does not say x, so you can't use the power rule. This is really just a constant, and the derivative constant is 0. And if you want to make these into positive exponents, this will be in the denominator, and I'll just use a radical symbol here to help me out. And the only reason I'm doing this is if I have to evaluating with a radical is much easier than a rational exponent. Okay, when does a function have a horizontal line? Well, right over here in this picture, at the curving part is where these horizontal lines occur. And so what we would like to do here is find the x values of any horizontal tangent lines. Well, this is a parabola. In fact, it's a parabola that goes up. So really the only place where it's going to have a horizontal tangent is right here at the turning point. Let's see if we can go ahead and find it. So I found the derivative, which is 8x plus 7, and I know I want 0 to be my slope. So I set these two equal to each other. So this is 8x plus 7. And so x will be equal to negative 7/8. So this is the place where the slope will be a 0 or horizontal. Now when you were back in Algebra 1 and Algebra 2, you learned a formula for the what we call the vertex. And the vertex formula for any quadratic is x is equal to opposite of b over 2a. That's what we taught you. And so this is our b right here. So we're going to take the opposite of 7 over, and we're going to take our a, and we're going to times it by 2. And look at that. These are matching. So what we taught you in Algebra 1 and Algebra 2 is matching, and we're using a different technique to find that turning point. Let's take a look at what normal line means. Normal line goes through the same point the tangent does, but it is perpendicular to the tangent line. So we want to figure out, find an equation of the normal line. Well, let me look at the tangent line, and then maybe I can find the normal line. So the tangent function is 3x squared minus 8x plus 1. I'm going to put the number 3 in here, and when I put the number 3, this is my slope. This is my point. If when I put 3 into my function, I got negative 3, and it's validated by the curve right here. Okay, so I want to find the equation of the normal line, equation of normal line, and I need a point and I need a slope. Okay, the point is still the same point where the tangent occurred, so that's 3, negative 3, and the slope has to be the opposite reciprocal because it has to be perpendicular, so negative 1/4. These are the two pieces of information, and so the equation of the normal line will be y minus a negative 3 equals negative 1/4 times x minus 3. And if I were to graph it, I'd graph it here at the same point, and my slope would be up 1 over 4, and my line would look something like that, and that would be perpendicular. Okay, differentiability with piecewise functions. So this is a piecewise function. I want to know if it's differentiable at -1. Weird things happen where the pieces kind of meet. So what we need to make sure is that the left limit is equal to the right limit. And we've got to make sure that at -1, both of these points are the same. So maybe we should do that first. So if I put -1 in here, I am going to get 5 minus 3 plus 2. And so that answer is 4. So at -1, I'll be at the point 4. And if I put -1 here, -7 times -1 minus 3, that's going to equal to 4. So the x value on the left and the x value on the right are both the same, so we know they're meeting up at the same point. But they have to meet, they not only have to meet at that point, they have to have the same slope. So the left derivative and the right derivative must be the same. Now we're not going to have to go through the definition of derivative. We can use our shortcut rules. So we're going to look at the left derivative, and that'll be 10x plus 3. And we're going to evaluate it at -1. And the answer is going to be -7. So the slope on the left side will be -7. Let's take a look at the right-hand side. The right-hand side, the slope is -7, always -7. So since these two slopes are the same and the two y values are the same, then we can say yes, this is differentiable. They're meeting and they have the same slope. What values of a and b would make this function differentiable at 3? So there's two things that have to happen. One, the two branches have to meet, and the second thing is the two branches have to have the same slope. So let's find the slope for the left side. It'll be 2x minus a, and evaluated at 3, it'll be 6 minus a. On the right side, the answer is 1. We want to make sure that these two slopes are exactly the same. So 6 minus a is equal to 1. Therefore, a is equal to 5. So we know that this number is 5. Okay, now that we know that a has to be 5, what does b have to be? Well, remember the two y values have to be the same. So if I put the number 3 into here, so that'll be 9 minus 15 plus 2. That's going to have to equal the value here, which is going to be 3 plus b. So this is going to be -6 plus 2, and that's going to be -4 equals 3 plus b. And so b must be equal to -7 in order for the two y values to be the same. So here are the two values that we must have so that they meet and they have the same derivative. And that's the end of the screencast.